Welcome, everyone. Thank you for joining us. Our Society of Physics students is really excited to have you all here. We've brought together a great group of professionals to share their experiences. And for those of us who are students in school, we typically only see what our professors do, and we may associate academia as the only path. And so afterwards, we assume that graduate school may be like the expectation. And here with our panelists, we have people who have and have not gone into graduate school. And then afterwards, in general, we assume that these paths must be linear. Like if we're working in astrophysics right now, then we have to do astrophysics for the rest of our lives. And so here we have our 5 panelists here to talk about their experiences and to share what they've done with their physics degrees. My name is Eliz Bitso. I'm a senior majoring in physics and computer science, and I'll be moderating the panel for today. And I use she, her pronouns. We'll be starting off with questions for them, and we have some questions that you submitted when you registered for the event. And then we'll ask them questions that you all have, so please feel free to put your questions in the chat and specify if you're directing them to certain people. Okay, for our panelists, if we could have like anyone who's not a panelist turn off their camera, we would appreciate that. Thanks, y'all. And for our panelists, please introduce yourselves and tell us about your path. Carrie, why don't we get started with you?
Sure thing, thank you. I'm really glad to be here, so thanks for inviting me. My name is Carrie Bridge. I am currently working at JPL as the Science Operations Team Chief for MSL, the Mars Science Laboratory rover. And I'm also the group supervisor for science planning at JPL as a whole. My background is I did an undergraduate bachelor's of physics at the University of Toronto. And then I did my graduate work also at Toronto, a PhD in observational astronomy studying galaxy evolution and formation, galaxy merger rates. After I did that and spent many, many nights observing on telescopes in Chile, I then moved on to Caltech for a postdoc for many years, and then also stayed on to be a senior scientist there for a little while, and then moved on to for a brief amount of time as an assistant tenure track professor. After which, that is when I made my transition from pure academia into what's sort of industry at JPL, where I am now.
Thanks. Nick, would you like to share next? Nick, I think you're muted.
Yes, I am. Thanks for having me. Yeah, so I started my career in undergrad as a physics major at RIT, and then I joined USC as a graduate student. Got a PhD in physics, working for Dr. Cresson, who I believe is your advisor. So after grad school, I was sort of casting about trying to decide what I wanted to do next, and sort of fell into data science accidentally. And so I first worked for a company called Overstock.com, which is a large online retailer. After that, I worked for Apple for a number of years as a data scientist and machine learning engineer, and I'm currently a principal AI data scientist for Anthem, or Anthem AI, which is a division of Anthem.
Great, thanks, Nick. Sabrina, would you like to go next?
Sure. So hi, I'm Sabrina. I use she, her pronouns. I graduated from UCLA in 2013 with a bachelor's in astrophysics. And after graduating, I actually spent a year working as an instructor in a program development for science education. Just a little bit of a detour before I went back to research. I joined HRL Labs, which is in Malibu, as an intern working on silicon materials characterization for quantum dot technologies, and ended up accepting a full-time offer there as a development engineer. And I stayed there for about 2.5 years working on control of spin qubits. And from there, went to Rigetti Computing, which is a startup in the Bay Area that was working on superconducting devices as a full stack quantum engineer. like a made-up job title, but basically I was an experimental physicist at Carnegie Computing. Also there for just over 2 years before joining a much smaller startup company in the Bay Area called Atom Computing, which was trying to build a quantum computer using strontium neutral atoms. And then most recently, I've joined the Google AI quantum team in Santa Barbara as an experimentalist.
Thanks. And Das?
Hey, hi. So thank you, Elizabeth, for the invitation. So my name is Das Pemmaraju. So I'm currently an associate staff scientist at SLAC, which is SLAC National Accelerator Laboratory in Menlo Park, California. So I did my graduate studies at Trinity College Dublin in Ireland. I got my PhD as a computational physicist. And then I moved to the States for a postdoc. So I did a postdoc in Lawrence Berkeley National Lab. And then eventually I moved to SLAC into this position as an associate staff scientist. And so most of my work is theoretical. And I basically use simulations that employ large-scale supercomputing infrastructure to do simulations of materials. Thank you.
Thanks, Das. And Solange?
Well, hi. I'm really excited to be here with you guys today. My name is Sulanj Ramirez. I am originally from Chile. I went to undergraduate over there at the University of Chile. Moved to the States for graduate school. I went to the Ohio State University to get my PhD. I then went to Caltech for a postdoc and another postdoc at the Spitzer Science Center, and stayed at IPAC, which does data archives for space missions for a long time as a staff scientist. When I was working there, and I was working with people on some of them at JPL, some of them at other institutions. I really liked working on teams, and somebody pointed out to me that that I had some facility to see problems in a broader way, and that it would be good for systems engineering. And I never heard of that before, and I started looking for research, and I thought, oh, this is something that indeed it may good for me. And I end up going back to school. I did a master's in systems engineering at UCLA and graduated 3 years ago. And right now, for the last 2 years, I am the project manager for the Sloan Digital Sky Survey #5, where I can use a lot of the systems engineering knowledge and the astronomy background that I have, because we are producing both hardware and planning a survey on the sky that is going to last for 5 years. And I'm really excited. I never thought that I will end up doing this when I started graduate school. So I'm really happy to tell you about it if you guys think that this is interesting. So thank you.
Sounds good. Thanks, everyone. Okay. How would you guys compare academia and the places you've worked, like in industry and national labs? And Carrie, let's get started with you.
Okay. Yeah, so I've actually, I feel like JPL is almost this intermediate step between pure academia and pure industry, in the sense that at JPL we have a science division where people are focusing primarily on research. So just like in academia, when you're in undergrad or in graduate school, you can kind of pay attention to what talks are going on and show up and listen to great research, cutting edge research that's happening. You can do that at JPL because of our Division 32. And then it also has a very campus-like feel to it when you're walking around the lab. So I think JPL is kind of that medium between classic industry and classic academia.
So maybe I can talk about SLAC and other Bay Area national labs. So yeah, I would say the overall environment at national labs is also quite similar. There is, because national labs are dedicated to research, and in fact most national labs in the US at least are close to or directly affiliated to other tier 1 universities. there's a lot of interaction with professors who work at universities nearby, and in many cases there are experimental researchers actually usually have sort of like a dual presence in the national lab and also in the university. And so yeah, the environment is pretty overall still pretty academic, I would say, but the main difference at national labs such as SLAC or Lawrence Berkeley National Lab or Lawrence Livermore Lab, which is roughly an hour from here, is that the research at national labs is more prescribed to the specialization of the given national lab. So at SLAC, we have, for instance, the LINAC coherent light source, which is a pre-electron laser, and experimentalists from all over the world come here to carry out their X-ray experiments. Similarly, Berkeley Lab has a synchrotron, and then Livermore is famous for the National Ignition Facility. And so yeah, most national labs are associated with some sort of large infrastructure, and the specific research at national labs is I mean, there's still a lot of open sky type research, but it's a little bit more prescribed to the specialization of the lab.
Thanks for sharing. And so, like, for our panelists, whether or not you went to graduate school, why did you choose this path, and how would you say this has impacted your career? Solange, let's get started with you.
Yeah, so by the time that I was an undergraduate in Chile, there were all these facilities, a new telescope coming online for a few years. It's quite amazing. It's the weather conditions there that are extremely good. So it was basically the desire to use those facilities that made me go into graduate school. And when I choose graduate school, I was looking for places that had infrared astronomy, because that was something that interested me. So I was looking out for a particular expertise to develop. And that actually impacted my career quite a bit, because I continued working on infrared astronomy for a long time, and it was extremely good choice for me to go to Ohio State. So, you guys are thinking on going to graduate school. One of the things that I will advise you to do is to really see more or less, what is the area of expertise that you're trying to develop, and go for there.
So Nick, would you like to share your experience?
Sure. So I did go to grad school at USC. As for why I chose the path, I think I was sort of just generally interested in physics, and probably when I graduated from undergrad, I didn't really know exactly what I wanted to do, and you can't really get a job in physics unless you have a either a master's or a PhD. So I went to grad school, and I think that even though I'm not really working in a field that's directly related to physics, sorry, I'm trying to use my screen as a light. Even though I'm not really using, excuse me, even though I'm not in a field that's really directly related to physics, I think I really learned a lot in graduate school, particularly, or I should say, physics is particularly good for generalists, because you learn such a broad range of things. So, I think we all took like a math methods course, both probably in undergrad and grad school. And it's sort of, all the random, things in math, actually not all the random things, but, some subset of them that turn out to be useful for people who are not just physicists, but also other things. And so I think, having that sort of generalist degree really, or I guess I shouldn't call it a generalist degree, but having that sort of generalist knowledge base helped later on, even though I'm not currently doing anything that's really related to physics.
And Sabrina, what's your experience been like?
Yeah, so I actually didn't go to grad school. When I was going out of undergrad, for financial reasons, it didn't make sense for me to go to graduate school with my family. So at the time when I was coming out of undergrad, I was thinking, oh God, why did I major in astrophysics? It was fun, but I'm like totally unemployable. This is awful. And I, at the time, was in contact with several of my professors that I had learned from when I was at UCLA, and one of them said there's this like really great opportunity to do some exoplanet research while also working in education. And so I took that opportunity to take a year to kind of figure out like, okay, I know I want to do some sort of research, but are there pathways for me to be able to do it without a graduate degree? And so while I was working in education for that year, I actually got in contact with another one of my older professors who had a contact with the group at HRL, which I ended up joining as an intern. And from there, I have benefited from just really, really great mentors throughout my time, and really great advocates that basically said like, oh, you know what, like you don't need a graduate degree to be doing the things that we're doing, and it has paved the way, I think, for more people without graduate degrees to kind of work in quantum computing. And yeah, it's something that I believe in strongly, that you don't necessarily need to go to graduate school to be doing these things. You can be trained to do them. And I was fortunate to have like mentors and other people, and people who hired me from other companies who believed the same.
Thanks, everyone. And so we see several of you here have like switched fields and career paths. How did you make this transition, and how did you come to this decision in the first place?
Yeah, I want to kind of follow up on what Sabrina is doing about the importance of mentors. I had a similar experience as the one that she was describing, and somebody pointed out to me a field, an area that this person saw that I had potential ongoing. This happened at about a time where I was really looking on what is that I really wanted to do later on. I had management experience. I have had experience working with teams, and I basically realized that I like that. I like working, on teams and getting people organized and getting them into a common goal that it is productive and creative and innovative. So I kind of found an area that I said, okay, if I go into systems engineering and I have this background in astronomy, then I can fill a void in the institution on really knowing methodologies on how to organize things. So I started looking into ways of developing that, and I found this program at UCLA that it was for people that it was working, that I had some years of experience working. And I said, well, why not? So why not? And that really opens the door for me, because I kind of understood what things were working on my team and which things were not working, and really opened the door for different things. Now, this is not something that it happened overnight. Actually, it took me quite a few years to realize that getting more training would have been beneficial for me moving forward. So those are things that when you are working, somebody gave me this advice that think about what is the next job that you want to do, and how you're going to develop your skills and the work that you're doing now to do the next job that you want to do. And by doing that, you reach out to mentors, you reach out to senior people, and basically explore. And that puts you basically in a state of mind that where you are like, okay, you know, what are the possibilities that are for me? And I really would encourage everybody and early on their careers to have their antennas open and trying to get into determining what are other possibilities, and always exploring what you want to do next, what you want to learn next, and develop those skills and move forward towards them. Yeah.
Thanks, Solange. That was really great to hear. Like, Nick, how did you make the switch from like physics to data science?
Yeah, actually, I wanted to say I think that Solange gave really good advice, and I wish I had heard that you know, much earlier in my career. So yeah, the way that I made the decision to go into data science is really just that I kind of fell into it. So it wasn't really a conscious decision after graduate school. I defended and kind of looked around and I said, you know, well, what do I do now? And you know, that's kind of, if you don't put that conscious thought into it that Solange was talking about, you kind of put yourself in this vulnerable position where you're kind of scrambling to figure out, okay, what do I do next? And I was very lucky that you know, I knew someone who knew someone who was looking for a data scientist, and you know, oh, here's Nick, and he has a PhD in physics. You know, maybe that's kind of interesting. And so I sort of lucked into it in a sense. But you know, if things hadn't gone exactly the right way, you know, my career probably would have gone very differently. And so I think that you know, that's really great advice to start, you know, to get your antennas out early and to think about what job you want next, and you know, to start looking for mentors, because that can really help you figure out, you know, where you're going to go in your career and develop those things early. So yeah, I think that, like I said before, I think that physics gives you a very broad sort of knowledge base, and you know, to a certain extent teaches you to teach yourself. And so you can pick up those skills that are relevant to other career paths.
And Carrie, I know that you like made this switch from like academia and like postdocs to where you are now. So would you like to speak to that?
Yeah, sure. And just I'll third the great advice from Solange. It's you know, I would say I was the classic, you know, from a little kid I wanted to study the stars, and so that was get the astrophysics PhD, do the postdoc, become the professor, and I got all the way there. In fact, you know, unfortunately, as I realized I remember sitting in my bed, I had one email open that turned down the offer and one email that accepted the offer, and it hours and hours to decide, do I go to this path or do I not? And it was, you know, it wasn't an overtime decision. It had to be an in the moment decision. But what I realized is that as I got closer and closer to what you do as a professor, I realized it was drifting away from the things that I really loved, which was working on the science itself. As a professor, you tend to do more teaching, more service work. I had lots of friends who had become recent professors, and I talked to them, and their work-life balance was non-existent. And it just seemed to feel like it was drifting away from what I originally, you know, had set out to do and what my new goals in life were. I at that point had 2 children. That was a changing dynamic in my life priorities as well. And so I turned down the offer, which my faculty, my supervisor at Caltech thought I was crazy because I didn't have another job lined up. I had a little bit more of my research money that could hold me over for 6 months, and then I spent that next 6 months kind of doing what I think it was Nick, like talking to people, and then talking to people who know people, and just trying to understand what jobs they did, and trying to figure out what are the parts of the job of research that I love doing. And I found that I love working in teams. I love doing research. I didn't need to be the person that wrote the paper. I actually preferred to like go after the really interesting science problems, figure out what observations we need to take, get the data, analyze it, figure out the answer, and then move on to the next thing. And so as I started to talk to people at JPL, which I was lucky because being at Caltech, there's a lot of connections in the astrophysics community between JPL and Caltech. Each person I talked to would hear the things I enjoyed and then connect me with another person. And then finally, I stumbled across someone who did what was called science planning at JPL. And that was this like holy grail for me because it seemed like I could work on all kinds of different spacecrafts, different missions, study the universe, bridge and use my science background to sort of bridge the gaps between the scientists and the engineers. And so that was how my transition sort of went. It was a little bit risky at the time, but I want to second that. I think I maybe wouldn't have been so, I wouldn't have got as far down the path if I would have kept reassessing along the way. Is this really what I want as my life changed? And as I saw closer and closer to what that next job, what they actually do every day, what's their day-to-day like? Isn't life like, is this something I want to do? So that was kind of how I made my transition from a classic academic path and then deviated into JPL, which I wouldn't say is pure industry, but it's close.
Thanks for all the really great advice. It's really interesting, like hearing like how to like keep on thinking forward, right? And like for everyone in our audience, please remember that you're free to submit your questions. Just type them in the chat to everyone, and then we'll be able to answer them. And I highly encourage you guys to ask questions since we have a great array of professionals here. And next, what have been some of your proudest moments? And Das, why don't we start with you?
Yeah, actually, that's a tough one. But I mean, it depends how far back I have to go. But probably the proudest. Well, I'm from India, so the most career-defining thing that will happen to you, at least back then, was you get accepted to grad school outside, so that you can go and do research. And so I would say, yeah, my proudest moment was probably the fact that I managed to get into the top 10 on the national graduate school exam that we have in India. And so that was my ticket to go to grad school outside. So yeah, that was probably my proudest moment. And it probably the most formative in terms of my career direction, because at the time I had the choice. I could go into the IT industry and become a computer programmer. So that was one thing you could do, or the other thing was to pursue physics, which is what I wanted to do as a kid. And so, yeah, being able to do that was quite career defining for me. So I would say that's my proudest moment.
Would anyone else like to go?
Sure. So proudest moment, I think for me, don't culminate in like necessarily one thing, but it's a series of things that for me personally have been the moments that have like chipped away at my imposter syndrome. So particularly in physics, and particularly I noticed in experimental physics as opposed to like astrophysics, where the gender ratio was a little bit closer. Being a woman, but then also not having an advanced degree in the field that I work in is fairly rare. And so I like have had this internalized kind of imposter syndrome that goes along with that. But the proudest moments for me are the moments that do chip away at that fact, where, you know, like people recognize you as an expert for whatever you're doing, that like people have conferences and like finding you to ask you questions to see like how things are going, because they knew that, you know, you were working on this thing. And it's those small kind of moments of, oh, like I'm the professional now, like I'm the person that should know what they're doing. And so I think those are kind of those like proudest moments for me personally.
Thanks, y'all. And then, so Sabrina, you brought up the imposter syndrome, and especially like what it's like as a woman in physics. And so here we have a lot of great women on our panel. And so like Dr. Bridge, Carrie, and like Solange, would you guys like to share one more times that you were aware of this fact? whether in overt or more ambiguous instances?
Yeah, you know, I remember Solange was from Chile, but and so she may have experienced this similar. But when I would do at grad school, when I do observations down in Chile on the mountaintop, I remember specifically being there for 2 whole weeks, and I was literally the only woman on the top of the mountain. And that was interesting, just from a perspective to realize that. Now, one of the great things is I felt like the people around me were wonderful. So even though that was the case, it didn't make me feel awkward or anything like that. But I will share an experience when I was a postdoc when I had my children. I had twins. And I remember my advisor at the time, who was wonderful, but you know, you could see the bias and the sort of older mindset. He said something along the lines to me of, I hope you don't go on the mommy track. Just that because now that I've had children, I could not also focus on research. And so I have faced this combination of, if I have children and I am a mother, that I cannot be also as equally serious about my research as I was prior to that. So that's been a challenge that I've had to, I've faced quite a few times and had to overcome.
Yeah, I want to share an experience that I have that it was quite enlightening for me. Probably happened like about 8 years ago. I was invited to a panel for review proposals, and I arrived at the hotel, and then, you know, going into the room where we were going to, all the panelists were going to have an orientation. And I walk into the room, and I look in the room, and I stop because I had the feeling that I was in the wrong place. And why was that? Because the room was full of women. And I thought, oh, this is awkward, because I realized that one of my colleagues were there. I said, oh, I am in the right place, but you know, what is really happening to me, right? Because I am a woman, and what is it that I'm not seeing myself reflected on my other women colleagues? And this, you know, talks about this issue of what is called the unconscious bias. There's other names that are related to that. And it really made me realize that I had my own unconscious bias in, you know, even towards my own, you know, gender. That was quite enlightening, because it was kind of like a tipping point for me, where I thought I needed to make more attention on this issue, and really be an advocate on certain procedures and process, especially on the hiring, to overcome the unconscious bias. And that is, you know, that is something that we all have, and we all have to recognize that it is present in our fields. Now, I see, you know, that things are changing, and there is more women and more diversity, and these are subjects that are being talked about. When I was in graduate school, nobody talked about it. It was kind of the big elephant on the room. And I think it is very positive to talk about these things and be empowered by the changes, because excellence is achieved by diversity, and I think that that is something very important for all of us to realize and work through it.
Thank you guys for sharing those experiences. Solange, I was like so surprised when that story turned the other way than I expected. And like, thank you for talking about like unconscious bias and how we can address this like issue of women in STEM through like hiring more women. And so like, in addition to like hiring more women, what are ways in which we can support women and other like minorities in physics and in STEM? Like, how can we encourage these groups to participate in STEM, whether from like your perspective as like career professionals, or even for us as like students in school?
Yeah, so one of the things that we do on our team is is really pay attention on the hiring process and define rubrics for looking into the applications. So we are basically getting our biases away and really concentrating on the expertise. We do have the problem is that sometimes we don't have enough applications of women and minorities, and that is a problem. A lot of people leave the field for reason, and maybe that is something that we need to address. What I think it is important for all of you that are younger is really to realize that significant change has already happened, and it is responsibility for all of us to continue on that path.
Thank you. Okay, we have a question from TV, and they ask, could y'all go through a day in your professional lives? Das, would you like to start us off?
Yeah, sure. Well, right now it's COVID, so I'm working from home, but yeah, otherwise, so at SLAC, as I said, I'm a theorist, so most of my work is with computing. And then the only other thing I would do that is different than working maybe as a computer programmer is, we talk to postdocs and students and interact with professional people. So in terms of like a day-to-day environment, that's how it is. It's basically as if you are in grad school, except now you're called a research scientist. And in terms of my actual work, I do specific work related to X-ray spectroscopy simulations because I work at SLAC and we happen to have the pre-electron laser. And so my work mostly involves doing simulations, doing physics-based computer programming to carry out those simulations, and then to try to get supercomputer time on national supercomputing infrastructures like the one at Berkeley. So and then basically we run our codes on the supercomputer and then analyze the results. And then we have we interact with the experimentalists. We help them analyze their data, and then when new observations are made that throw up new questions, and then we try to develop theories to understand those observations. So it's sort of a feedback mechanism between experiment and theory, and my job is basically to sort of facilitate that in the context of a certain set of experiments at this pre-electron laser. Yeah, but the activity mostly just looks like as if you're in grad school, just doing research.
Nick, would you like to share a day in your life?
Sure. So I'm leading a small team at Anthem, and so typically every 2 weeks we kind of take stock of where we have progressed on our sort of larger projects, and try to figure out what we need to do next. It's this whole agile process you might have heard of. And so we, write tickets and assign tickets to people, and so that's sort of like a thing that happens on about a bi-weekly cadence. In terms of like day-to-day activity, we start with like a stand-up, sort of figure out what the progress has been since the previous day, if there are any, if anyone has run into any problems, and then sort of start work for the day. In terms of the actual tasks that we're doing, it's highly variable. So for anything in data science, it all comes down to the data, and so we end up spending a lot of time worrying about where data comes from, how it's processed, and writing basically data pipelines to process, ingest, and transform the data, and then build models based off of that. So, for example, if you want to predict someone's A1C score, that's something that's relevant to people who have diabetes. You might want to ingest a large number of features, including historical A1C scores, and then train some sort of model based on that. So a lot of it is writing code related to processing data, and then writing what essentially amounts to modeling code. So training models and of different types. So typically some sort of neural network, but it can be something much simpler than that. So I realize this is very vague, but it's sort of a big field. There's all sorts of things that you can do as a data scientist. Oh, and you know, it can be more specific than that. It can be you know, specific sort of an analysis of, you know, some experiment. You might run an A/B test, depending on what kind of data scientist you are, and you want to do just simple hypothesis testing, or you might do some sort of exploratory data analysis where you just, you know, look at your data and see what's there, you know, explore correlations in it and things like that. So.
Great, thanks. Brenda has a question asking, how do you manage your work-life balance? I know like Carrie touched on this when she was saying, when you were talking about like your twins, and so like, would you like to start us off?
Yeah, sure. It's a challenge. It's a challenge day to day, especially now in the COVID era, because we're doing remote operations. In fact, we're operating the rover remotely. Now, typically we do operate the rover remotely at JPL from Mars, but now everybody's at home trying to do it. And so I'll be trying to work with the engineers and plan the next drive while my kids are, you know, running around and right now in homeschool. So one of the ways that I've been trying to balance it is really good time management and organizational skills. And I couldn't be doing it without my partner. We usually on the weekend look at our calendars and see where our bad days are and good days are for meetings, and how we're going to divide up. Okay, you can be able to help the kids with their schoolwork, and this afternoon I have a red meeting. My kids call them red meetings, which are meetings that mommy can't move. Those ones have to stay there, and we have to work around them. We know we've implemented things around here where we have a green and a red dot that are on the outside of the office doors, so they know which parent they can bug when, depending on the meeting. But honestly, it comes down to time management, and right now it's really, really hard. So there's a lot of long hours. I'm definitely working more hours than normal, but you know, COVID aside, back in the day, again, it's time management, but it's also discipline in the sense that one of the things I felt with academia is that I was always on. I was always working at night. I was working on the weekends, you know, to stay up on the latest research, to get, as my kid pops in the back, to get my papers out and get those proposals written. And so there was always guilt if you weren't working. And one of the things that I found, and one of the things I made myself do as I transitioned out of academia, was to really try to put boundaries on my time. That, you know, when 5 o'clock hits, you know, I do really shut down. Now, because I'm working with the spacecraft on Mars, I do have to monitor as things come in, because I'm the team chief if I need to react quickly. But everyone sort of really shuts down at JPL at 5. You'll see emails drop to very low numbers. And on the weekend, again, no emails. We try also to encourage people not to send emails after 5 p.m. unless they're mission critical. And so putting those boundaries on can help you to, you know, make those lines between work and life a lot more easy to deal with, that I struggled with in academia.
Yeah, can I add something? Because I kind of agree more on what Carrie is saying. I also have 2 children. They're not twins, so I have no idea how you did it, Carrie, but I did it one at a time. And both of them now are very independent. One is in college, the other one is in the last year of high school. But when they were little and they were in school and you know, it was really important to keep the time and focus my attention on what I was doing at the moment. So if I was in the office when my kids were in daycare, really concentrate on my work things. And when I needed to go, basically switch into the family mode. That really helped me go into things for myself, and get both of them going and have that balance. That it is difficult because things come up in both ways, right? It come up on the work that you need to take in your attention when you are at home, or it come back at the office because kids get sick and sometimes you just need to run and take them to the doctor or why not. So the time management and the organization is actually key for doing that balance. And I think that I'm going to pass on some of your techniques, Carrie, to people in my team, because this time of COVID is particularly difficult because you don't have that space separation that helps you switch from one to the other. You are at home, working at home, embedded with your family environment. So that is extremely important, as it is important to have a partner that supports you as a professional, and really work it out as a team.
Yeah, and just to briefly follow up on that, one of the things I find in grad school when you're writing papers, you can spend so much time refining and refining and refining. And when you get into a job, and you know, whether it's like you have a very intense job with lots of tasks, or you're trying to do a better work-life balance, whatever it is, knowing when, and this is very hard to learn, knowing when something is good enough and stopping to move on to the next task is really an important skill to learn. Because I've, you know, as a grad student, spent way too many weeks trying to refine a paper that should have gone in a month prior, and I could have moved on to the next task. So that's a really good skill set to develop and learn when is good enough so you can move on to the next thing and stay productive.
That's a really good point. Okay. Yushao asks, can a theorist in graduate school still get an engineering job? Das, what are your thoughts?
Yeah, certainly. Especially if the engineering job is more on the software side or data science side, as opposed to a hardware side, I would say, because as a theorist in grad school, you develop a knowledge base, especially in physics, as Nick mentioned earlier, that is pretty general and I would say quite transferable to other fields. And yeah, but as a hardware engineer, I think that's probably tougher because you probably need some training during the transition phase. I would say nothing is impossible, but that's probably unusual. But yeah, definitely on the software side or data science side, the skills are quite transferable, in fact. So that's what I feel. Maybe Nick can comment as well.
Yeah, I would say yes, but you probably won't be doing theory. So, you know, knowing theoretical methods is useful, but a lot of the time, you know, everything we do is just empirical, and more related to like the way that you would sort of think about analyzing data from a physics experiment. That's very similar to a lot of what we do as data scientists.
Zihan would like to ask, what do you guys think are the most important skills that we should learn in graduate school, other than the ones that you've already mentioned?
I would say
time management. Sorry, just saying that.
I think one of the things that's useful is soft skills. Learning how to hear points of view and ideas from multiple different teams and be able to build consensus between those teams. That's a very coveted skill to be able to have. It's also a skill that they look for when they're looking for people to move into leadership roles. So that's a good skill to have, is work on soft skills. There's some really good books on that. One in particular, I've taken the class that JPL offers, but there's a companion book called Crucial Conversations. It teaches you really great techniques and starting phrases to use when you're in sort of intense conversations with people, emotions are high, how to sort of neutralize the conversation and then move the team forwards to a good solution. So that's a great book, teaches you some really good techniques. On the technical side, from an astronomer's point of view, and then what I'm seeing at JPL when I hire people in science planning is I'm feeling a lot of the need for people who do, in my field, science planning, also having some computer software skills, being able to, not necessarily to be computer scientists where they're going to actually be building the code from scratch, but an understanding of, say, for example, Python at JPL is key to understand. I can read someone's Python scripts and kind of debug it, or at least understand what it's doing, and maybe make some additions to it. So I'm noticing that shift in also needing to have some computer programming skills, because at least at JPL, what we're seeing is a movement towards automation. We're trying to automate instruments to make science decisions, given high radiation environments and that sort of thing. So, you know, getting some computer software skills is very helpful as well.
Yeah, I would just add one more thing, but I think this is more relevant to people who would probably want to continue in academia, which is the importance of networking. In grad school, I think soft skills partly cover that, but it's important to be known within a field, and especially if you have a supervisor who is not doing the work of publicizing your work actively so that other people become aware of your work. I think you have to take the initiative to reach out to other people and try to build your network. And I think that can certainly help when the time comes, either, you know, if you want to get a postdoc, or eventually, even if you want to leave academia, and, you know, if you have a number of people who can write good letters of recommendation and so on and so forth, it cannot hurt. So yeah, networking is important.
Yeah, to build up what Dawes said, the networking, one of the things when people come and talk to me, one of the things I try to tell them is use the person that you're talking to's network to build your own network. So after you've just had a conversation, let's say I'm networking with someone, they've learned about what I'm interested in, I can say something like, okay, you know that I enjoy this and this, can you recommend anybody else that I should talk to? So now you're going to leverage their network to grow your own. And that's how you can just build it and build it. And that's eventually how you may start to figure out what you might want to do in what career path. So it works in both looking for what you might want to do with your life, but also once you're even there, to grow your network within that particular field.
Right, I've heard that 80% of people have gotten jobs from their like second degree network. And so like, that's a really good point. And like Sabrina, since like you didn't go to grad school, what do you think are skills you've learned along the way at like the different places you've worked, like HRL and those like various startups and now Google?
Yeah, I think in particular, one of the great things about grad school is that it teaches you how to really get into the depth of something. Right, like you become a technical expert in your particular thing. One of the things that I've noticed in industry is that there's much more of an emphasis on breadth over depth. And so, you know, when I was first starting my career, it was very much like, okay, I want to learn a little bit about everything so that I can figure out where I want to like find this technical depth. And I found that the skills that are most useful for that, number one, are actually software skills. So a lot of times the information that you want is much more easily read in software than it is in the technical paper. Oftentimes, like, you'll find experiments and you'll find like snippets of code that are doing exactly the experiment or the pulse sequence or something that you want to do, and it just makes a lot more sense in code than it does, say, like written buried somewhere in some paper. So I would say software skills help a lot. Networking, as already mentioned. So there are outside networks, but also I think, especially in industry, like tapping on your mentors and tapping on your managers. That helps particularly for number one, like work-life balance, and number two, actually like getting the skills that you need to advance in your career. You know, when you ask like, this is where I want to be in 5 years, like they will give you the tools that you need to do that. So making sure that you're honest with yourself and then open with whoever's in your management chain or anything like that about the things that you do want to gain. I found that those things just across the board have gotten me to where I am.
Sounds great. Okay. Thank you to all of our panelists for your time, and thank you to everyone who came and like joined today and like participated. This has been like really great, and we're going to send the link for our like mailing list for our Society of Physics students. Oh yes, Dimple sent it. Thanks, Dimple. And thank you all so much for coming.
It's a pleasure.
Thanks.
Thank you. Bye-bye.
Thank you.